Hey, this is a quick introduction to maps. I'm going to take you back in time to solve a mysterious epidemic in London, 1854. Pretend you're living in London, and a newsboy yells out as you walk by, "Extra, extra, read all about it. 70 people dead of a mysterious illness." You continue to walk by. Next day, you hear, "Extra, extra, read all about it. 135 people dead of a waterborne illness." You continue to walk by. Third day, see the same sooty paper boy saying, "Extra, extra, read all about it. 75 people dead of a mysterious airborne illness." What do you think you might do if you lived in London, you had a little bit of time, a little bit of money saved up? What might you do during a mysterious epidemic of unknown origins? Think about it. If it was me, I'd probably leave town for a little while. Maybe go to the Midlands. Maybe go somewhere else. Just keep that in the back of your mind as we explore this. What are these two things on the left and right? Think about it. There are two bar charts. The one on the left it's like basically a frequency of deaths over time. So on the x-axis, it's dates from August 20th to late September. On the y-axis, it's the number of deaths over time. So as you see here, the number of deaths, very few in late August and September. It peaks really quickly on around September 1st. Then September 2nd, it peaks around 1:30 and then kind of quickly goes down. On the right, X and Y are basically the same, but it's cumulative deaths instead of just total deaths per day on the left. As you see, it kind of, again, nothing through late August, and then it kind of quickly increases and it tapers off. What are any of the problems that you may have with this? What are the good? What are the bad? The good is that it helps to show what happened, how this cholera deaths happened, like that it happened really quickly in early September, was really bad, and then quickly tapered off. The bad thing about it, it's descriptive. It's not very explanatory. I'm going to show you another slide, something visual. Let me know what. Yell out quietly depending on who's around you at your computer. What is the next slide? Answer it. It takes one word to answer, and do it on a count of 3, 2, and 1. The next slide is it's a map. It's a street map. This is called pre-attentive attributes, where you can kind of notice something really, really fast within like hundredths of a second what something is. We've seen so many street maps over the course of our lives, you know exactly that this is a street map. Anything distinguishing on this? Probably really simply, in the middle is a brewery in yellow. On the upper left, there's a workhouse, and as you see on Broad Street in the middle, there's a pump. And as you see scattered throughout this whole map, there are a bunch of small rectangular black rectangles. As you might imagine, this is information that Dr. John Snow used. He used a map to help solve this cholera crisis. He had a theory that he developed over time that cholera was a water-based problem. So he thought it was from dirty water, hence there's a pump in the middle of Broad Street that he was noticing. That was his theory, and he used this epidemic to help prove this point. The pump at Broad Street is where he thought it was the leak of waste and sewage was happening, because there's so many deaths as you see around it. As you move further and further away from the pump, it's less and less. He used some very smart detective thoughts based on his thinking and using this map. The brewery, as you see inside it, has no deaths, no black rectangles. When they talked to the proprietor, they had many, many people there. As you might imagine, this is London back in the old days. A number of guys who worked in a brewery might, instead of drinking tainted water from a pump at Broad Street, might just drink beer, saved by beer. So if you are worried about cholera ever, you're thinking about it and you have access to beer, drink the beer. The workhouse up in the another yellow building up in the upper left, has a couple of desks, but not very many. Many people are there. The workhouse was used for poor people to kind of work and to kind of live on a subsistence level. What they had there, as you might imagine, they keep people there. It's kind of like a sort of a soft prison, like where you can kind of come and go, but it's more like a place to work. They had as you might imagine, because they had so many people there, they had their own pump on site. They had their own water well, so they had their own water source. So they had less deaths per capita because of that. Something they also found is that they found a couple of cases far away. There were a couple of girls that went to school at Dufour Place, which is a little street between the workhouse and brewery. They lived far away, but they went to Dufour Place and would get water from the pump, and they died, unfortunately. And then also there was a woman and her niece who lived far away, and they both died. And what they found was that they got water from the pump, and they had it like shipped to them because they liked the taste of it, and unfortunately it killed them. So this is sort of the idea of thinking through using a map and aggregating visually displaying data. And Dr. Snow makes his watertight case in this case. So as you see here, what you might think that Dr. Snow would do is he has this theory that it's tainted water that's killing people. So what he said to the parish at the time was, with a lot of people dying, we got to get rid of the handle to the pump. If there's no handle, people can't get water. So what he had, and you see here again a couple of they're basically like bar charts. There's two of them, one on the left, one on the right, and they kind of do different time frames. As you see, September 1st to 7th in the left one, September 3rd to 9 on the second one. That's the really key date. What Snow, if you think through this, the handle was removed from the Broad Street pump on September 8th. And what this sort of shows is that, on the one on the left, I get it, on the 8th, the handle's removed, cases drop precipitously. But in fact, that's really not the best, most accurate. The one on the right is a little bit more accurate because it takes about 48 hours for the ingestion of cholera through water, tainted water, for deaths to happen. So as a result, although the pump handle was removed on the 8th, it would take a couple of days for this to come into effect because of the time it takes to transmission. So from this, you can learn that depending on how you divide up data, it can be more or less representative. And in fact, probably the best representative of this is this map here, where you see the frequency over time on a daily basis. That helps to show most specifically what's happening. If you're a public health reporter seeing this, what might you try to argue for if you want to make a sort of a sensationalistic, catchy story? You know what I would say is the valiant Dr. Snow, with his theory of cholera in hand, on September 8th argued to the parish to get rid of this pump handle. And as a result of that, he stopped central London from having the worst number of deaths since the Black Plague. But the problem with that, of course, is this is a really simple point. Removing the handle is not enough. It takes about 48 hours, and that's one part. And then also people largely left London after they heard of the deaths. So as a result, it wasn't so much that Snow solved this problem for this circumstance, he solved it for the next time. Again, people had already left London. A better title for this story would be: A Clever Medical Detective Identifies Cholera and Water as Cause for London Health Crisis. To finish up, what do you think happened to the place where the pump was? There's a John Snow pub that helped to show where the iconic thing happened. Thanks for watching.